Has this ever happened to you? You're sitting in a parking lot, you're enjoying your music, dropping some serious bass, and when you try to start the car, this happens. I know what you're thinking, just keep the car running. That might work, but it might not. Your alternator doesn't make full power at idle, especially if you've got an upgraded high output alternator like this one right here. Some of those don't put out any power at all at idle. What most people do is they just hook up a voltage meter, but that won't always solve the problem because a battery can still read 12 volts and still be too dead to start your car. It turns out there's a simple fix. This right here is a battery monitor. Not only can it monitor your battery capacity and your voltage, you can also measure the current generated by your alternator and the current going from the battery to the amplifier. You just have to hook it up and it's a simple fix. Or well, it should be a simple fix if the instructions made any sense. More on that a little bit later. When you crack open the box, here's what you're going to find. The first thing is this big chunk of metal. This is a shunt. And this is where the action actually happens. I think the manual actually calls it a sampler. There's two sides. One is labeled battery negative. The other one is labeled load negative. It comes with these little plates that mount on the post and some screws with standoffs. All of the power coming from your battery to your load, your amplifiers, your radio is going to pass through this thing right here. So this monitor can track your current flow and your battery state of charge. More on the shunt later. The next part is the brain box. The manual calls this the module. You connect the shunt to the brain with a short 4-pin wire. This is the display. It comes with a long telephone wire style connector. You run that wire up to the front of the car, mount this on the dash somewhere so you can keep an eye on your charging system. You will need to fabricate some kind of mount for it. That's a video for another day. But you don't have to do that because it's got a cool feature that we'll talk about in a little bit, so keep watching. Alright, so how do you hook it up? We start with the shunt, and the most important part is the shunt goes on the negative side on the electrical system, the ground side, not the positive. The shunt's got two set of terminals. One is labeled battery negative, one's labeled load negative. According to the instructions, you hook the negative battery terminals to the battery side. You connect both your power source, your charger, and the load to the load size. When you're wiring up the shunt, don't be surprised when you get some sparks. That happens. In a car, that power source is going to be your alternator. Here on the test bench, that power source are these two power supplies. One thing I did notice in the manual, it did not say whether or not it was safe to install all of this stuff under the hood of a car. And I kind of thought that was weird. You would think they would give you specific instructions on whether or not that's safe to do. So as with any DIY project, this is a do-at-your-own-risk kind of thing. Now, the load, of course, is going to be your amplifiers or other parts of your stereo or whatever else you happen to be powering. People use these in all kinds of situations, RVs, campers, that kind of thing. This particular model is a 600 amp model, so it's got two big lugs. The smaller models only have one lug on each side. You're going to need some 3/8-inch ring terminals and crimp those onto your power wire. I just noticed this. I ordered the 600 amp model, but the shunt says 750 amps. Okay, that's cool, I guess. You can tighten these down with a 17 millimeter socket. Next, connect the shunt to the brain. Look for a short jumper with 4 wires. There's only one 4-pin connector on the shunt. That's where it goes on the shunt. On the brain module, it goes in the middle on this side right here. Now for the confusing part. You've got to power on the brain. There are 3 different power modes. There's the internal supply, aka self-power, external power, and external power with a relay. Well, self-power sounds obvious, right? Self-power clearly means that the unit itself has some type of battery in it, and it will run on its own. That's what you would expect, and if that's what you would expect, you would be wrong. It does not appear to have a battery or anything like that. What self-power appears to mean is that you're going to use the battery that you're monitoring as the power source source for the monitor. To activate self-power mode, you flip this brain over and move the dip switch to 2W. Then on this green connector right here, you run a jumper from the positive battery terminal to the terminal labeled VSNS. That's your voltage sense lead. The brain is then grounded to the shunt and you've got power. That's true for all three modes. No matter what mode you're in, you're going to run a positive wire to the VSNS lead on this green connector. That's your voltage sense line. It reads the voltage and in self-power mode powers the device. Self-power mode works just fine, but there's always a but. If you use self-power mode, you have no way to power off the monitor. It's going to draw power when your system's not in use. It doesn't pull a lot of power, so it's only going to drain your battery if you leave it connected for days at a time. And of course, you'll know it's dead because you have a monitor. That's what the monitor is for, so you know the battery's dead. To engage external mode, you just flip over to the back of the brain and flip that dip switch to 3W, that's 3 watts. And in external power mode, you use all three connectors on this green connector right here. Can anybody tell me what you call this style connector right here? I know it has a name, but I forget what it's called. Help me out a little bit. Tell me down in the comments. Now I am assuming, and you really shouldn't assume, but I'm assuming that in external power mode, you can run a switch or maybe connect your amp turn on lead or maybe an ignition source. And that way this will power the unit on when you turn on your system. That way it's not running when the car is not running. Now relay mode, the instructions are even more confusing. To use relay mode, there is an extra pigtail in the box. That pigtail goes right in here, and so this is going to be where your power and ground are going to come from. And again, I'm assuming you can put a switch on this. Then there's an output wire. That output wire is going to go to your relay, and you can use the relay to disconnect the battery from the load. I'm going to install this on my test bench. It's a 64 amp hour headway bank, and so I'm not worried about the slight current draw from this little monitor draining the battery. I'll show you in a little bit when I get it hooked up just how little the device itself is going to draw from the battery. So for me, self-power mode works just fine. If you're installing this in a vehicle, you want to use one of the other modes so it's not on and draining your car battery when you're not using it. Before you connect the brain and power it on for the first time, you want to make sure the battery has been fully charged. Then after you make the connections, you grab the display and go into the menus. You got to set your battery capacity and set your state of charge to 100%. You have to do this in order to get accurate monitoring of the battery. If the battery is not fully charged and you set it to 100%, then you won't know when you're actually fully charged. Actually, you'll be able to tell. I'll show you that in a little bit. You know, unlike a lot of YouTube channels, I don't have big corporate sponsors, so I can only afford to buy and test things like this because of the generous support of my patrons and channel members. So I want to say thank you to all of my patrons and channel members. Patrons get behind the scenes content and early access to videos, and $10 and up patrons get their name right down here in the video, while $25 and up patrons like Jonathan, Joaquin, JD America, Timothy, and Bo get a big shout out in the video. Thank you guys. I appreciate your support. If you'd like for me to keep making videos like this, then head over to Patreon. Sign up for as little as $3 a month. Okay, everything's hooked up, but we're not quite done yet. I want to show you what happens when I power on the test bench with the power supplies on. So right now I've got my test bench radio running, just the radio, no amplifiers, and we're getting 0 current draw. So how in the world is that possible? How is it that I have my radio on the test bench on and I'm getting no current draw whatsoever? That's because the power supply and the load are on the same side of the shunt, and the power supply is providing more than enough current to run the radio, so no current is running through the shunt to or from the battery over to the radio. Watch what happens when I turn the power supplies off. Now you're measuring the current flowing across the shunt from the battery. I'm going to play some music while I work on other projects and let the battery drain down just a little bit. Okay, the battery has drained down a few percentage points, and I'm going to turn off the radio and turn on the power supplies, and then power is going to flow from the power supplies across the shunt into the battery. Now that's really good if your goal is to monitor the battery, and monitoring the battery is something you probably should do. But maybe you might want to do more. Maybe you want to know if your high output alternator is giving you all that current that you paid for. Maybe you want to know how much current your amplifier is drawing. The way it's set up now, it's not going to give you that information. There are several different ways you can solve that problem. Connect both the alternator or your power supply and your battery to the battery negative. That way, no matter where the power for your amplifier is coming from, you'll get that reading going to the load across the shunt. And that will tell you how much current your amplifiers are drawing. Or you could connect your alternator to battery negative and then the battery and the load itself over on the load side. That's going to monitor the power coming from the alternator. That's not in the owner's manual. Here on the test bench, I'd like to be able to measure the load going into the amplifier. So what I'm going to do is I'm going to grab a second one of these things. The first one's going to go in place just as described in the owner's manual. It's going to monitor the battery. The second one is going to go between the first shunt and the rest of the test bench so I can monitor the current going into an amplifier when I do an amp test. I'm going to hook that up right now. Oh hey, I forgot the coolest part. This thing's also Bluetooth. You can download an app and monitor this from a phone or a tablet. How cool is that? I'm Justin. This is the DIY Audio Guy YouTube channel, and I will see you on the next adventure.